Okay, well, I guess we'll go ahead. We'll invite up Jim Kajder. Kajder.
Not a problem.
I'm sorry. CLD. He has this theme, the code review process and tools. So let's get you going here. Is this thing on?
I don't know. I'll probably walk around.
Okay, good.
I can't sit still in the presentation. It just goes dead. I go dead. So, yeah, bear with me. I can't sit and do presentations. I can't stand it. Okay. Anyway, CLD, as it says on the view graph, been doing this probably about 5 years before this, Visual Basic before that. Does anybody here remember the Digital Equipment Corporation of Axis? Anybody? I used to be a system administrator. This gray hair was well earned. 30 years in this business. Don't admit that to everybody. All right, so this is what I'm trying to go over here. A little bit of background about why in the world we would do what we call them peer reviews, but the presentation was called a code review. Why we do them in our particular operation, kind of a walkthrough of one that we did, a little discussion. And I want to make sure that I thank Nancy Hollenbeck and Brian Powell because I stole some material from them and my coworker for reviewing this thing and hopefully cleaning it up so it's legible. All right, what are we doing here? Code review. Wikipedia talks about a code review. They say a code review, systematic examination, often known as a peer review of your code. It's intended to find and fix mistakes overlooked in development, and it's supposed to improve the overall quality of software and the developer's plural skills. I think the last thing is the most important. When I can actually break away from the doggone meetings that management makes me go to, we're a group of about 10 software engineers and 5 hardware engineers and technologists, and I work at Sandia National Labs. If you've ever heard of it, 8,000 people, command and control kind of an organization, hierarchical. Oh my God, I go to way too many meetings that have nothing to do with programming. But when I can break away from that, I actually learn from every code review I do for somebody else. So those of you that are in a group that has more than one programmer, please, for God's sake, review your peers' code. That's the most strongest thing I can say about that, because you'll learn from what they're doing, because they're going to approach the exact same problem you have, which in my case is automating a test from a different perspective. So, if nothing else, do them. It reviews, as we say, identify problems and exchanges knowledge. Really, it's to improve both developer skill level, the person that wrote it and the person that's reviewing it. And also in our case, since we've got 10 people, dozens of automated testers out there, we need to have some standardization, if nothing else, for the user experience. For the rest of you, if you're writing in a large company like we are, if all of your user interfaces are different, you will drive what we call our operators of the testers insane, and the calibration and maintenance technologists will hate you. Because they're the ones that use it day in and day out. You don't. I always have to remind myself, the code is not for me. It's for them. And also, in our case, if I get hit by a bus or at some point retire, somebody else needs to know these testers that I've developed over the years. The best code reviews are the ones that actually get done. I just mentioned that for my own organization. We don't always remember to do them. I don't know if anybody else has that problem. These are rules I'm just going through. This is actually lifted out of a procedure that we have printed for our organization to follow. So what we say is the peer reviews have to be done by developers that never touch the code. If you think about that, that actually makes sense. I don't know about you, but I can't find my own mistakes. It's the way it is. We had to put this bullet in because it's kind of commonsensical. All the code has to be complete, and the unit tests have to actually pass. We've had people try to do peer review on stuff that I don't think a broken run really needs to be peer reviewed. I think it needs a little bit of preliminary. Just suggesting.
Level 3.
You know, or if I run the software and I can see that it obviously doesn't perform the test, could you just clean it up before we review it? I think we're wasting both of our time. Just a suggestion. And we very rapidly found out that, in fact, we stole a spreadsheet that I guess Brian Powell did, or was it you, Nancy?
That was a joint effort. I'm sure we plagiarized from somebody somewhere.
Looked like Jim Green had touched it also, maybe. But anyway, there's an Excel spreadsheet, and we use. I'll show that in a little bit. But basically, we found if you want to run everybody out of the room doing a code review, try to fix the code while you're reviewing it. Everybody that's there will leave very quickly. It just, it's not a good plan. You're not here to justify your work. I know for some people you should take great pride in your work. But if somebody's saying that your code is incorrect or could possibly be restructured to make it more maintainable, you just need to write it down. That's just a suggestion. Don't try to fix it during the meeting, even if it looks like a quick fix. I'm sorry if I'm preaching, but that's something we found.
Hey,
These are the activities we do, and the ones that are I'm sorry?
Can I make a comment on the last
Sure.
slide? Your statement about waiting until the code is complete and ready to be reviewed, absolutely true, but I also think that there's not enough emphasis given by the community on a pseudo design review. It can be less formal, or maybe call it an architecture review, but before someone goes off and does, hours and hours of coding, to get some kind of agreement from their peers that, yes, this is a good approach to solving that problem. That way they don't get all the way to the end and like, oh, well, I'm not gonna go back and change it now. I got it all done working.
I have to apologize to everybody, bear with me. I work in what's called the weapons complex. I've got a written procedure I've got to follow that's probably been out there for decades. I've got phase gates. I've got to actually do a requirements review. If you've ever heard of Michael Fagan out of IBM, we'll do a Fagan inspection of the requirements. I've got to do a design review. Now this is the system,
right.
So the reviews are participatory between the hardware and the software engineers. We're building a rack of automated equipment. But both of us have to be in the room for the design review, and then also for the end of the construction phase, which is like the pre-qual phase. I got all those phase gates built in, but for those people that don't have to deal with such a rigorous process, yeah, you should have a design review. That would be a lovely thing to do. Because there's no point in writing all your code and then finding out that fundamentally your design's bad. That would be frustrating. In our particular process, we don't have time to do all of these steps all the time, or it isn't worth it because everything isn't of that level of importance to the company. Obviously, an acceptance tester for something that we're going to sell, yeah, it's going to get more attention to something that's just an in-process check, tester kind of a thing. But anyway, we go through functional testing, BI analyzer, panel code, verifying documentation. We still use use cases for those that are familiar with them to document the design, and then we have to document our test cases. So that's how we'll review those when we have time. Configuration file verifications. We generally use INI files, but I know some folks here probably are using XML or relational databases. What I'm talking about is key equal value. Any tester we have has to have some kind of a volts per volt factors or other things like that, setup values if it's a digitizer, those kind of things all end up in a key file somewhere. So checking those out. And then finally documenting that the peer review is complete. Functional testing is a good step. I wish we had more time for it. What we're actually doing here is when we can is getting out to the actual piece of equipment or the nearest facsimile and running it. We end up doing that as we go through here. We're looking for functionality, aesthetics. Aesthetics would be kind of like what I touched on, ease of operation from the end user. What I'm talking about there is that we know that we have a common team of people that run around and calibrate and maintain all our testers. We've already been told more than once it drives them insane when every tester looks different. So folks that have worked on other testers will come and say, hey, this is a great calibration, but looks completely different than the one that I already shipped last year. Can we change these buttons around or something, or rename them? You've got the same button with a different name, that kind of thing. Go ahead.
You're lending on the idea that maybe you should go into your functional testing before you go into the code review.
When we can.
You don't have that feedback.
We'll do this on, as I say, for things that are acceptance, where it's a component that we're actually going to put in stock, that kind of thing, yeah. For an in-process tester, we'll skip this because I can never get enough time in the schedule. Go ahead.
Do you have any kind of style guide in place to define
Sure.
how they should be?
I didn't show that yet.
Too much.
Okay.
What did I do with it? We're still using one that we got from LabVIEW Journal, which is your site.
Yes.
Yes. So we go through, and so some of the things that we talk about were like here. Front panel, avoid an unpleasant front panel, make sure it's clear, present in an understandable way, groupings, transparent labels, all of that. Yeah, we go through and try to do that on an individual basis. A lot of this stuff is things that you can't find in BI Analyzer. It doesn't test for it, so it requires another developer or a human being to check for it. I'd encourage everybody, if you're working in a team, to make up your own style guideline. We're slowly customizing this one. We haven't gotten very far. Two things that are important that we found. We reuse code a lot. And the functional test is the best way to find out that somebody didn't look at everything when they reused the code. It's very interesting to run a particular calibration and have it come up and tell you that this is the PT1234 tester. Well, no, it isn't. This is the 3456, and you copied the code and never fixed it. If I don't catch it when I'm peer reviewing your code, for damn sure the operators in Caltex will, and they'll think less of you because of it. They like to think that the software was actually, for the tester they're running. So, for those of you that reuse code, it's nice to have a colleague go through and check that, because I don't know about you, but I'm fairly blind to that kind of stuff. So you'll miss it. The other thing, having somebody that's worked on other testers is corner cases. What I try to do is check things that I've had to do Rev B on my own tester because it broke. Hey, if you do this and you type numbers where it's expecting letters, bad things will happen. Yeah, I'll try those on your tester. That's just a simple example, but I've broken more than one person's tester just trying things that broke my own. I figure, why should they have to go through the same aggravation of having to rev their tester 3 months into the field? So getting an experienced developer to come and try to break your code is a good thing. Somebody that's working in the same field as you. We asked that the people that actually wrote the code run VI Analyzer because at least it catches the simple stuff. It doesn't do any good to ship something with wires under objects or similar problems. It's going to be very difficult for the maintenance programmer that gets called in because you're on vacation or you got pulled for a tiger team and you can't work on your own tester if they can't read your code. VI Analyzer at least catches a lot of the readability things. If you haven't used it, I'd encourage it. The one thing I will mention about VI Analyzer is you really have to customize the rules for your own environment. For example, there's a very fine rule in VI Analyzer that looks at your front panel and it wants you to use all dialog controls. There's a reason for that. If you put your code on a Macintosh or put your code on a Linux machine, it will look like the native operating system. Well, we work for a large company. All of our testers have Windows-based computers. I turn that rule off. I could care less what my code looks like on a Linux machine. You may not have that luxury. But I turn off any rule that's associated with that kind of stuff because it doesn't apply. It applies to somebody but not to us. And of course, it's not a requirement that 100% of the issues that it reports get fixed. For example, VI Analyzer will get all excited about wire bends. I don't know about you, but if the doggone wire is labeled and I can see where it goes, I don't care if it has a few extra bends in it, I'll get over it. But the person that wrote VI Analyzer doesn't have my same opinion. Nancy's laughing. You know what I'm talking about. There's a couple roles in the VI Analyzer that seem a little picky to me, Nancy. A little.
No, Darren does a good job.
He does a great job.
He does a fantastic job.
For all of you that don't know Darren down here, yes, great programmer, great job. But his
Fastest LabVIEW programmer.
I'm sorry? Fastest LabVIEW programmer.
Because in iWeek, he's the one that is consistently winning the fastest LabVIEW programmer contest, although Robert Mortensen from Salt Lake gave him a run for his money this year.
Yeah, but in any event, I had the privilege of going to iWeek and listening to him do a presentation. He's a fine man. But his opinion on some of the things, and I've already said my piece. Some of his rules I either turn off or slightly ignore because I think he might be being a little picky. Your opinion, you can have your own. Anyway, handling code verification is the most important thing. We'll go through that on a piece of code here, but what you're trying to do, we're looking for maintainability. That second bullet is really the most important thing to me. If I'm looking at your code and you're working with me, and I'm worried that I might have to maintain your code if you're out, I gotta be able to read your code. If it doesn't make any sense at all, we use, for example, as a rule, state machines in our programming because we go through a lot of situations where you have to initialize equipment and then set up the equipment, perform the calibration, analyze the results. Well, we got states for all of that. We got an error management state. If you don't use that style when you program yours, how the heck am I going to debug your code? I'm going to be totally lost when I walk up to it. It would be a heck of a lot better for me if you use some form of a state machine with labeled states so I can understand what you're doing. Obviously you could use, like, God forbid, you could use sequence diagram. What is stack sequence diagram? I mean, the code would run, but how in God's name would I maintain it? I'd go start graving. And we were given a piece of code by a contractor. You're laughing. We had a contractor supply a piece of code like that. It was stack sequence. I couldn't read it.
We still have code like that.
And I couldn't read it because we're not used to it.
Oh, it takes me 30 minutes to figure it out.
I dealt with this 2 days ago. There was a stack sequence with 27 cases in it.
Yeah. I rest my case. I'm telling you. Don't try to catch that during code review. If you do that, give it back to them. Ask them if they clean that up. Error management. Rob and I have difference of opinion on error management, but it's all good. Sometimes Rob will say that an error will never occur in this piece of the code, therefore I don't need to wire the error lines. I have gotten burned by that, so I tend to try to ask Rob to please wire the error lines, even though he doesn't, never mind. Yes, so, but we do look at that. Documentation is important on block diagrams. I know the users never see it, but if you're in a situation, and if you're a lone wolf programmer, maybe it doesn't matter. But if you're working in a group with me, for God's sake, please put some comments on your block diagram, because I'm going to be looking at your code and I have no idea what you're doing. Without the comments, I'm probably going to be lost.
I'll toss up, if you're a lone wolf programmer and you come back 6 months later.
Yes.
You won't know what you're doing.
Tom, when we're our age, you come back 2 weeks later.
Coming back with 5 years later.
I'm there.
This user interface documentation, what I'm talking about, a lot of that is, we try to like hover over the, we'll have something where the user has to enter the metadata to test the parts. We haven't quite gotten to the point where we're scanning all the parts in, so people are actually typing in like lots and serial numbers and different things that are important to the test. We're going to hover over those controls and make sure that you put some tooltips, because the user's walking up to this thing and they're not you. They're not a programmer. You got to give them a little bit of help so they know what they're supposed to type in this lovely field that you put, you know. And just, so we'll look for that kind of
This
stuff.
is another good place for you to bring up the fact that you want to look at the corner case and suggest what happens when you enter this in that field.
Oh yeah, yeah.
Oh, yeah.
We tried to pick that up when we were doing the functional testing, but oh yeah, we've had fun breaking people's code. You know, what happens if I put a tilde in the middle of your serial number? Always fun to try, you know, stuff like that.
We're not military, but I let my wife play with the DOI.
Not a bad idea.
Because she knows nothing. I'm just saying, right? I mean nothing. So it's great when she plays with it, because she'll do something, because I get a habit of pushing the buttons in the sequence, right?
Yeah.
But she'll just go.
In a more formal outfit like we are, we actually have what, 2 qualification engineers? Well, they're not software programmers, so I tell them to go break it. Generally, their background is quite different. They're actually, you know, certified by ASQC or whatever kind of stuff. You know, they have a completely different business background than the rest of us, so they can break stuff for me, and they're kind of fun to turn loose on it. And they'll try all kinds of crazy stuff. Or if you really want to do the acid test, see if you can get one of the foremen to loan you an operator.
Well, you find somebody too.
Oh yeah, no, to me that's the acid test. I go to the Caltech team lead and see if I can borrow a Caltech, or go to one of the foremen and borrow an operator. Oh my God, they'll break your code.
Just find a guy who breaks it. We had a guy who, rather than stick his tongue out when he was looking at a screen and confused, would unconsciously move the mouse around and click the left button. He didn't know he was doing it. Never knew how he got to wherever the hell it was. But I bring him back up. If it was time to test something, it's here you go. This confuses you so much you start doing that, and we're in trouble. You know?
The other thing that you want to do with user interface, and we were having problems with this, but your pop-up panels also should be somewhat consistent. So we try to do everything possible to make pop-ups occur. Pop-ups will occur like when in corner cases, you know, the code will say, hey, you know, something's wrong, fix this, you know. We try to go through them and bring all of those up, make sure that the wording on those is appropriate. All right. Documentation and configuration file verification. Documentation will get caught in our environment by the qualification engineer, so it's not really critical. What we would be looking for would be this is just the normal bad, no, you're probably not surprised. The normal bad news is that people will do the design, and then they'll do the code, and then they'll fix the code, and the design will be for Rev A, and Rev B works completely differently. I don't know if you've ever read anybody's design documentation, but we've had that, to where the design documentation no longer describes the code the way it works now. So another programmer will pick that up immediately. It's like, wait a minute, you don't do this anymore. You used to do that. So, you know, it's just little stuff like that. And then also just test cases. What I'm looking for there with the test cases is just make sure, did you write any, and, you know, can I read them in case, because I'm going to be the one, if I have to pick up your work and, you know, revise it, I'm going to have to run your test cases over again, you know, regression testing. It would help if I could read them. So, you know, we'll check for that kind of stuff. Configuration files. We do stuff with more than one person. Almost always we'll have 2 people working on a large system. I cannot tell you how many times I have put in a factor for a volts per volt on something, and my coworker has another routine that touches that. Maybe I'm doing like a calibration that only gets run annually, and he's doing one that's a daily ver. Well, he'll touch the same key, but he doesn't know I made it, so he makes another key. You have no idea how much fun that causes for the folks that are using the testers to have two different keys that actually are the same factor, used by different pieces of the code. They'll change one, and you can imagine. Going through your configuration file and making sure that you only have one and only one key value pair that describes what you're doing is, yeah. I guess it really doesn't matter if only one person's working on the code, but when you have two people, it's actually fairly common for that to happen. You'd be surprised. You have a file with like 100 different keys in a complicated system, and there'll be two of them that are doing the same thing. Go ahead.
So you said you use INF files?
Yeah, we're just using those. You have to bear with me. Up until about 5-6 years ago, was doing Visual Studio, and that was the way we did it, and I just kept doing it.
Well, I love INF files. They have a lot of fantastic benefits, but I just recently updated a config file system for Freescale, and there was so much data involved in it that to write a decoding, encoding routine to pull the data in, push the data out to the config file would have been prohibitive.
Yeah.
So I ended up just doing an XML dump of the entire functional global variable, basically, that we're using to pass data back and forth. That was really the
I can
solution.
relate. What I end up doing is doing like a for loop, and then passing in arrays of things for the sections and the key names, because otherwise the code becomes much larger than you could ever, you know. Even VI Analyzer complains how wide the code is. Yeah, but if you put it in, yeah, but you're right, in XML, and we were talking about it. Yeah, I should move to XML files. Me and Paul, I haven't done it yet.
Your config files start getting really big, they'll slow down a lot too.
I haven't noticed that, but maybe ours haven't gotten that big.
I kept calibration data in config files for a while and learned very quickly that if they started to get real big, actually they were a memory leak, but they got so big that all of a sudden they worked slower and slower and slower.
For what it's worth, my feedback on that, we noticed that in LabVIEW 8.2. Somewhere along the way around 2011, the doggone thing was rewritten.
2009, I
okay,
think.
It was rewritten.
Somewhere around there, yeah.
It was rewritten, and it got a whale of a lot faster.
Got faster?
Yeah.
Okay. So we had the same experience about 4 or 5 years ago when we were still using like 8.2.
Trim white space embedded in that.
Oh my lord! Oh my lord! Trim white space was getting called, I swear, thousands of times, and it was storing things in strings and then pulling them back out and putting them into other things like doubles or whatever. But trim white space was just eating us alive. I mean, you could go get coffee while the thing was updating the file. It was bad.
Yeah, it was.
But that got massively improved right around 2009.
Yeah, it was around 2009. It was a significant change because prior to, I think it was a functional global variable under the hood, the way the old Semaphore and Rendezvous VIs were written. So that got changed, and so I think it was queues under the hood. But the funny anecdote around that, which is it's a good story for us, is when we're writing libraries, making sure we have a public interface and use the project library and make sure no one calls code they shouldn't. I had a customer, this kid's a rock star, he didn't call everything that was on the main palette for the configuration file VIs, he was calling sub VIs. And we changed all that. So all of his code broke because of that. And so the lesson there is forcing that public interface for anything we write for somebody else.
Okay, in our particular environment, well, probably everybody's environment, you're working on one thing and then you're working on something else, you're working on something else. If you don't document the fact that you did a peer review, no one will remember in 3 months. So let me break out of this for a second and show that file momentarily. We ended up using, well, as I already admitted, we took NI's code review checklist. This is one I filled out for stuff, but oh, it's not fitting very well. It looks better on my laptop when I'm not on, never mind. I've got a wider screen at work. But you're going through here in the blue section, these are things that it says complete during the review. We haven't changed these titles, but what I typically try to do is get code out to people at least a couple of days before I ask them to meet on it. And they go through it themselves, or I go through it myself and mark it up. So I filled all of this stuff up before I even sat down with the developer. This is just me going through the code at my desk saying, hey, this I didn't like, this I didn't like, that kind of thing. When we get together in the meeting then, the developer gets to see this for the first time, and then there's the green and the red. The green is like when you're investigating it, if you decide that what I said is a valid complaint, you actually decide to fix it, then you put it here. If you think I'm full of crap, which, you know, hey, 10 different software engineers, 12 different opinions. It's okay if you don't agree with me. You put it down here and say, nah, you know, Jim's crazy. I'm not, you know, it's perfectly fine the way it was. Go ahead.
1967, is that a real?
Oh, this is lifted from, when did you guys get the name of that?
You know,
Were you having fun with
Brian
this?
Powell is in the doghouse. That's when I was born.
This is the NI original one, so I am not responsible for those dates. But yeah, issue resolution is
So that
you know,
was
the ones that you decided to do.
Yeah, that was all.
All right, enough said.
You got
If you
about-
want a copy of this and you didn't get it, you don't have to get it from me. You can get it directly from Nancy. It's on the.
LabViewJournal.com.
Yeah, if you haven't looked at that, there's some neat. Well, obviously there's neat postings on there, but you can get it from there.
You say what language was this done in?
I'm sorry.
5 minutes.
What language was this done in?
Uh,
It was in 67?
well, I don't even want
For
to know.
Excel.
I was just saying you got 5 minutes.
Oh, geez, I gotta move faster. I'm sorry.
Total, yeah.
Slow.
Is there time for discussion afterwards, Bill?
Um,
We're blending a little in the middle.
That's
what
kind
I'm-
of already blended in, yeah.
Oh, okay.
Oh, good. I was up to the sample point anyway, so this is good. Let's get LabVIEW running and see if I can find that thing. All right, so and this is typically what I would do. We would get together and we would evaluate one or more code modules that do something meaningful for the customer. This particular library is doing an instrument. Oh, great. The screen is really having fun with me. I'm sorry. Looks great on my laptop. Let me bring it down so you can see it. Okay, so this is doing, as it says, an instrument self-calibration. What we would typically do is look for something that had the words top level in it or something like that, and open that and then start drilling down. So as we were reviewing the code, we would open up the top level and then, all right, oh, so the front panel's sort of on the screen. Okay. Good enough? All right. And then pop into the block diagram. Just thought I'd show you this. Oh, wow. I have no idea what this looks like on my desktop. It looks great here.
You're
Get it on
fine.
the screen so you guys can see it. Note to the next presenters, you guys are going to be suffering for this too. All right, so this is actually a style of programming that we've used off and on for years in my particular company. It's we would call it a queue-driven state machine. The queues are an array of enums, and it's taking the next one off and going through it. So we've stacked a bunch of things up. We would look for this at the front end. Okay, so you want to do an initialize, you want to knit your instruments, and you want to update your panel at the front. We'd ask you to pull that down during a code review if you hadn't already done that. If you'd collapsed that so I couldn't see them, that wouldn't be good. I'd want to come in and know what I was supposed to, what was supposed to happen before I got to touch the keyboard. So we would go through an order, and we would go through the particular, states. And since I'm running out of time, let me just jump to the one. This was going to be a stump the programmer question, so you can tell me what I found. Lance and Clay and I were doing this code review for Nathan. Nathan is a CLD, and that's lovely. This is what he presented to us. So we got into his perform cal. Is enough of that on screen? Yeah. So we got to this point in the code review, and I'm looking at this and I'm saying, oh, cool. You've divided up your error line. You've got the same thing here that you can't read that's doing instrument calls for self-calibration. So this is the same VI. And you're trying to get some efficiency here. You're running them in parallel. No problem, Lab, you can do that. So then we looked at the code, and as soon as this came up, we said, hey, you got a problem here. It's not going to do what you want. So here's the test for you. What's wrong with this code? Just seeing what you see.
Stretch out the top of that. You can see the thing all the way across.
Which? Oh, sorry. Yes. Okay. So what's wrong here?
It's missing clone.
Bingo! You win. That's exactly right. And the other thing, which is a huge eye strain, you can see the grid. That's the two things I notice immediately in a clone program when you bring it up. One is it says clone and it has a goofy number next to it, like 456 or something. And the other thing is, you can't edit it. So LabVIEW very politely takes away the grid on the front panel. So as soon as we saw that, we stopped it, because we write code like this. We will put either loops in parallel or whatever. And the reason that he's doing this is because if you've done self-calibration on instruments, you know that some of them can take like a minute or 2 minutes or 3 minutes to self-cal. And this is something that you want to do with instruments every 24 hours in order to get the best accuracy out of them. So if you've got a handful of instruments, you know, we'll do them in parallel. So anyway, as you all know, then you just run in here and change it. Make it some form of clone. And it's not going to show it. I save it. I don't even know if it'll show it now. Sometimes you have to get out. Yeah, there it is. It's showing it. I don't know if you can see this. I can see it from here. The grid's gone.
Yeah.
It's also showing, if I expand this out, that's the first thing I noticed when I was sitting there. I was like, there's something wrong with that. That's not a clone. Because the grid's gone. The grid was not, I can see the grid. So that's the two things. And then the other one, of course, is that 50,004 or whatever that thing says, clone at the end. That's the other key. But we knew going into it that Nathan was intending to run this code in parallel, or otherwise, why in the world would he have done that construct? You know, he'd have just done them in serial, laid it out. So we knew he was trying to gain efficiency, so we like, it's not working the way you think it is. And then he went back and checked, and you can do a couple of different things like desktop execution trace toolkit, and you can see that. You know, what will happen, of course, for those that aren't familiar with it, is the first one that hits, it'll just block all the other ones, and they'll just run through one at a time. So we caught that and fixed that for him, and that was probably the best thing we did in the whole doggone code review, was fixing that for him, because it was a performance issue and he hadn't caught it. All right, so anyway, that's the kind of thing we would do during a code review. Let me bring the last thing up, and that's about it. Sorry I ran over, Myron.
Okay, no problem.
If you haven't already looked at these two things, you should. Peter Bloom has a fine book, LabVIEW style. It's a few years old. I like it a lot. It's got a whole chapter in it on how to do peer reviews. If you don't want to buy it on Amazon.com, borrow it from somebody. One of the other people you program with should have one. I mean, I got one on my desk. It's a good book. Peter Bloom's got a lot of good ideas. Bloomy Controls, if you haven't ever talked to them. Nice people. Nancy and Brian did a whole anti-week presentation on this, and I stole some of the stuff from there. Any questions that I can answer?
Quickly. Okay, thank you.